Hi guys, I just wanted to see you to see this beautiful trace here. So what are we looking at? Well, here's what we're looking at. The top trace is my new 100 times probe, and that's set at 200 volts per division. That's what it comes out to. So you're looking at like 1130 or 1030, 1040 volts there. Now the bottom trace is something altogether different. That's the trace from our current probe, which is here. Here's our 100 times probe connected, along with ground, and ground to the current probe as well, and there's our current probe.
Hi guys, Twinbeard back here in the Sleep Freak Pirate Broadcast Laboratories, and I've been playing with a little Joule Thief, which I find to be a fun little circuit. You see we've got our Energizer AA cell there at 1.174 volts. We got a big old diode there. There's our toroid. It's just a little green fella. I put about 20 wraps or so of number 26 and number 22 wrapped by filer together. The 22 is the power into the circuit, really. So there's also a number 22 secondary on there, which we have this handy little scope across right now. As you can see, it's giving us a frequency output in blue on the top right of the display is 75 kilohertz. Switching out. We got a couple of rheostats there, so we're gonna play with that here in a minute. And this is a RCA SK3024. Simple little bipolar transistor. And we've got these two variable resistors in series. And we're outputting, according to our scope, between the red line, the red horizontal line, and the blue horizontal line. There's a happy middle ground somewhere, I'm sure. Okay, we're putting out 2.5 volts here. And it's telling us we're at 75 and change kilohertz. And here's our waveform. Peak to peak's pretty good. Our LEDs are really dim at 75 kilohertz. So this is a coarse tuning knob, and this is a coarse fine. So I'm gonna tweak the fine a little bit. See our waveforms growing a little bit and our frequency's going down. We're at 71.5 kilohertz now, and I'm going to hit the coarse tuning, and that's 50 ohms and 1500 ohms respectively on the fine and the coarse tuning. Alright, we're down to 60 kilohertz now. About 50 kilohertz at this point. You can see our wave shape starting to change a little too. Our LED's bright as hell now. And we're at 21 kilohertz. And we dropped out. So that's right where it kicks on there. So I'm going to see if I can tweak the fine-tuning knob a little bit. See how low I can get us on frequency, on operating frequency on this device. Alright, so the LED just kicks on at 9.8 kilohertz. That's about 15 kilohertz there. $20 kilohertz. $24.42 kilohertz. So our 50 ohm resistor will take us, variable resistor will take us all the way up to 24.42 kilohertz. And now I'm going to start cranking the coarse tuning up. And we can push that up all the way to, you can see our voltage is increasing as we lower the frequency there to a certain point as well. Alright, and we just dropped off. So I'm going to do the coarse tuning over here. I'm going to play with the fine tuning a little bit. Alright, there's a definite frequency peak here at, looks like 77.06 kilohertz. It's about as high as I can get it to tune on 1.158 now. Okay, I'm going to sweep that again. Since we're on the high end of what it can do, I'm going to sweep it down to the low end. And you can see our battery voltage is dropping.
Really getting at was, you can see this beautiful wave stacking here. And you can see the relative phasing of the current wave there as well. You got several current waves stacking there too. I've got that on 5 milliamps per division. Okay, so you can see that's probably 12 or 14 milliamps at 1000 volts. That's as accurate a reading as I can get. I mean, it's more accurate than this beast here. It's more accurate than the fluke meter. That's about as accurate as I can get, I think. So that's 14 milliamps times 1000 volts with like 14 watts. So we would need like a whole amp point one something. 1.15-ish amps or so driving this to equal the power that's coming out of it. And guess what? That doesn't even count the juice that's getting dumped into this battery over here. Because if we pull that battery out, we can really make this current and voltage, both of them, just go through the roof. But I just can't get over this beautiful trace. And more optimizations yet to come to the Flowerpower device. I think probably what I'm going to do is just build a whole stinking new one a complete version 2 Flowerpower device instead of stacking on new features that I come up with and new ideas and ways to change it. I think I'm going to leave this device the way it is and let it ride into history that way, and then we build a whole new one with a lot more fine tuning and some matched coils. Ooh-wee. It's gonna be fun. Okay, enjoy.